Hello, the focus of this particular video lesson is going to be on how we use the graphing calculator in context, and more importantly, how do we write our responses once we've actually used the calculator. So, some review of some skills. We talked about this function in class. It is the function that describes the area of a can as a function of the radius of the can. Now, it's not written here, and it should be. First of all, this is in square inches and radius is measured in inches. The second thing that should be here is there's a fixed volume. We don't know what the fixed volume is, but we're assuming that there's a fixed volume for this can. So if we make a bigger radius, it's going to require a smaller height. A smaller radius would require a bigger height so that we can always have the volume be the same. And whatever shape we decide, it's going to have an effect on our area. Anyway, to get this into the calculator, we need to type it in using y's and x's instead of a's and r's. So I have the equation in there. What I did is I explored the table, and by exploring the table and looking at the different kinds of surface areas that emerge, I was able to produce an appropriate viewing window so that I could see the whole graph and nothing but the graph. The part of the graph that's important. So clearly, if I keep on putting x's larger and larger, or smaller or larger radii, I'm going to get more and more surface area. But it's going to start to get into the area where we're talking about ridiculous, unrealistic shapes. So this is the stuff of the graph that's the most interesting to me. The only context clue I had was y equals 120, so I knew when I set my y values they should be in the hundreds. But I just went a little bit bigger than that so I could see the whole graph. Anyway, as far as skills are related, we were in class looking at what happens if A, the area, is 120. So we produced this equation, and this is the equation we're trying to solve. I don't have the algebraic chops to solve this equation, but what I can do is put in 120 for the other y value and find out when will the values of the first function be the same as the values of the second function, which is the horizontal line. So to get these intersections, all I have to do is go to second, calculate, and choose option 5 for intersect. So here's option 5. Then I need to tell the calculator which curves I want to intersect. So the calculator is flashing right now on the blue. So that's one of the curves I want to intersect. So I just hit enter. And then I can see the cursor jumped up immediately to the red. So that's the second intersection curve I want to see the intersection for. So I hit enter again. And then finally, the calculator is asking me to guess. I guess it's going to be about 4.15. And I hit enter, and it says 4.17. So I had a pretty good guess. So the calculator was able to solve an equation that I myself could not solve. I do know now that when x, or the radius in this case, is 4.173, that the y value is going to be around 120. There's another intersection there, so I need to find that one. So I go back to calculate, and I do option 5 for intersect. But this time, before I hit anything, I'm going to cruise over so that the cursor is nearer to the other intersection on the curve. So now I'm closer to the first intersection than I am to the second, so you can see this is going to be the area that the calculator is going to start looking for solutions. And so I hit enter, 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 and indeed it found the correct solution. It gave me the appropriate x value, and we still know there's two solutions. So the other thing that we asked to do is, what if I'm not interested in what makes the surface area 120, but rather I'm really interested in what makes the smallest possible surface area. So to do that, I can just, first of all, I'll clear out y2, if I can. I'll clear out y2, and just make the graph. If I want to find the lowest point on the graph, or the minimum y value, I just go to calculate again, and looking at my calculate options, I'm going to choose the minimum option. So I choose 3, and now the calculator needs to know where should I start looking for the minimum and where should I stop. So I can see here that at 1/2 it's not the minimum, so that's a good left bound. So I can type in 0.5 or 0.6, that'll work, hit enter, and the calculator is going to start looking right there and tell me where the lowest point is, but it needs to know when to stop looking, so I'll just put in 3 for x, and that says where I should stop looking. So the calculator is going to look at this part of the graph and tell me the smallest y value on that part of the graph after I hit enter, and it does now tell me that when x is 1.518, that the y value is going to be the smallest, around 43.46. So that's all well and good, but really the question becomes, now that I know how to use the calculator, how do I write down my work to defend and support the work that I've been doing? So this is an example of how your work should look at the end of the day, and we could see all the details that are important. So I'm just going to point them out really quick. First of all, you notice the graph is made with a ruler. I make the scale with a ruler as well, and I use a couple of points from my value feature on the calculator so I can get this curve as accurate as possible. Then I show the equation. This is the given information which creates an equation. I have to write the equation down. So I'm acknowledging that if I had the algebra, this is the equation that I'm solving. Thankfully, my calculator did all the busy work for me and produced two solutions, so I expressed those two solutions using the approximately equal sign. And if I really want to bolster my work, I will add this extra bit saying that I can make two different cylinders that will have the same surface area, one tall and one short and wide. The other thing that I didn't include in this write-up, and I'm really mad at myself now, is I didn't actually write in English the interpretation of this result. So I should make sure you mentally add that to this picture. And then here, I'm actually using a notation. I said the area minimum means that when the area of 1.52 radius is going to be the smallest possible area, surface area at 43.46. So that's how I got that lowest point. This is the notation that I use, and then I answer in context. So to require the least amount of materials to make this can, set the radius to be about 1.52 inches. Then you would only need 43.46 square inches to make the can. Hopefully you find this helpful information. Again, the two different skills are how do we use the calculator to get everything that we need, and that is we use second calculate rather, and we can choose between value, minimum, maximum, or intersect, depending on what question we're being asked. And once those questions are asked, then we have to actually produce a write-up that shows the graph that we saw, detail all the different important parts of the graph, label the points that are solutions to my questions over here. So hopefully that's helpful. Have a great day.